Hello everyone, Daniel is here, and I get often asked about the DataFlint open source, what it is, how it works, and what's the value. So today I'm going to give you a short overview of what's going on. So if we look, this is our website. What it does, it adds another tab to the Spark Web UI. So bear with me, I'm going to show it all in this demo. So first you can visit the GitHub page and give us a star. That's always fun. Easy to install, just 2 lines of code, be it using PySpark in the config, same with Scala. It will download our jar. It's in Maven. It's Apache 2 license, so no worries regarding security. We keep all your data and metrics in your cluster, nothing comes out. So you can do it using the Spark submit. So let's open up Cursor. That's my IDE of choice. And let's see how it works. So I have a basic ETL, here the 2 lines of code that add the latest DataFlint jar. Here I configured the Spark Web UI, the port, and also the history server that I'll show later. But if we look at the ETL, we first read some files, so I'm going to run it locally. We have some sales-related files, then we filter them by quantity, and save them to Parquet, and partitioned by the quantity. So on the face of it, quite straightforward ETL, and when I run it on large data, takes plenty of time. Also, this small data is quite slow. So usually what we do to debug and understand the root cause is use the Spark Web UI. So first I'm going to run it locally. Perfect. You can see it's running. So usually that's how it works. You need to manually refresh because it's not really responsive. If you go to the data frame tab to understand where's the problem, it's quite verbose. So you're not sure. That's where the DataFlint tabs come in. So you see this is real time. You can see read, Parquet, filter, sort, and write. So this is the query, how the data flows and what operations are happening. And okay, now it's finished because it ran locally, so it's quite short. What I can do is go to the history server. I can see the jobs, the stages that ran, input, output, what happened. So we scan Parquet, we filter, sort it, and then execute insertion to Hadoop, whatever, about what's going on. And if I hover over it, there's so much information here. Also in the scan Parquet, where's the problem? Why it's running so slow? You can look also at the physical plan, try to understand things. Not easy. That's our DataFlint tab, our open source feature. And this is history server, so it's the same also in real time when it's running. I click the DataFlint tab. I can see a high-level summary of what's going on, duration, input, output. DCU is approximation of cost because we can see on which machine it ran. Usage, spill, which is super important, could happen a lot and would slow down Spark jobs. Shuffle, also due to the spills. And idle cores, how much of the cluster, the cores in your clusters, are idle and not working. Also important metric. So let's go to our run. And I can see it now in a way that is much more human readable, right? Read, Parquet, filter, sort. I can see what happens to the data, how many partitions, average file size, where it's stored. Then filter, what happened, what the condition, how many rows will filter, what's the percentage out of the total data that I filtered. Then I have the sort, and then the write, which is also much more human readable. The format, the average file size, how many partitions, how many files. I can see already that sounds like a lot of files, 5,000. And here on the query, I've already alerts and warnings. It says reading for small files and also writing small files. Both alerts with recommendations how to fix them. So again, this is our open source, free, safe, you can use it, and it gives you a recommendation, but it's on you to implement them. We also have a heat map. So if there is some super complex query, you can get lost. The heat map helps you. We're going to show it soon on much more complicated query, but the alerts give you a list of all the alerts and warnings, resources, the configuration of the cluster. And if I go to the history server and try to find a more complicated query, let's see, I ran TPC-DS, so it's like 100 queries, very well-known benchmark. I ran it on EMR, so the data frame tab, let's open one of the queries. And let's say you're trying to understand what's going on and debug this. Again, requires expertise. I hover, so much information, like hash aggregate and the keys, not easy. Let's go to the DataFlint tab. So soon I'm going to see the whole list. Let's filter by the name and find 99. Here it is. And now you can see the same query, but a much more human readable visualization of it. You can zoom in and see what's going on, how the data flows, and a heat map, right? So it shows where I am, and it shows in red the parts of the query that were slow. So here you see there's red. So we know this part of the query is the problematic one that I should focus on. And I have also a warning. We can see it here. If I zoom in, it says reading small files as well. Right, so this is the TPC-DS query. Also here we have something orange, repartition by hash. I go to the alerts, and there's a lot of alerts of reading small files. Cool, so that's the DataFlint open source. It gives you not just a better UI, it shows you exactly where the bottlenecks, pinpoints them, and gives you recommendation for fixes. So this is something that can transform the way you work with Spark. Again, open source, use it as much as you can and enjoy. And see you next time.